Hi everyone, welcome back. In this video, we are diving into the confidence interval for the population mean when the population standard deviation is known. This is a part of chapter 6 in Data's book, and it's a really important concept, especially if you want to understand how to estimate value using sample data. Let's start with the big questions. What is a confidence interval? A confidence interval is a range of values. It's tell us where we think a population mean might fall based on our sample data. Think of it like saying, I'm pretty sure the average number of steps a nurse takes per shift is between 7,000 and 9,000 steps. That is confidence interval. In this section, we are working with a special case when the population standard deviation sigma is known. This means we already know how they spread out the data is for whole population. It doesn't happen all the time, but when it does, we can use the C-score instead of T-score. Here is the formula we use when sigma is known to find the confidence interval. Let's break down the part by X bar is the sample mean, C is the Z-score that match your confidence interval, and sigma is the population standard deviations, n is your sample size. First, let's take one example to find the critical value. C is we call critical value corresponding to C confidence. First, I will take the 90% confidence, C as a 90%. So then we know that using the probability rule, area under the curve is 1. So in order to find the yellow region, total yellow region, that means each we have a two similar area. First, I will find the total yellow region. In order to do that, equal 1 minus confidence 0.9. We have to convert to the decimal value. Then you will see that this is total area of the yellow region. So to get the each one, so I will divide by 2. So equal this value divide by 2. Then you will see that the 0.05 is for each one yellow region bound. So then next we have to find the critical value. That's mean given probability of 0.05, we have to find the CC value corresponding to the probabilities given. So we are going to find the CC. Then Excel has a built-in function. I will type the C equal and normal distribution and standard normal inverse value. Double click it. Then you have to give the probability. It's 0.05. Just enter it. Then you will see that we got the negative 1.64485. You can round up for 2 decimal. Round this value, comma, 2. Then you will see the negative 1.64 is the critical value for corresponding the probabilities are 0.05. Let's go to find another example. Confidence is 95%. Confidence. That's mean. So first, I'm going to find the both yellow region. That's mean equal 1 minus 0.95. Then to get the first, I will find it. Then to get the each of one, because the total area is 2 times this yellow regions, each one region. So I will get this value divide by 2. Then we got the 0.025 is the probability. Then to find the critical value corresponding to the probability of 0.025, then equal normal. Standard normal distribution, probability is this. Just enter it. Then you will see that negative 1.95996, you can round off for 2 decimal, round, let's come out. So then this is the way how we can find the critical value in order to find the confidence interval. First, I will use this example in order to find the confidence interval. First, we have to find the point estimate for the population mu. We know that we can find directly using the x bar equals sigma x divided by n. That's mean we have to get the total data points and divide by number of data points. In here, I convert this data as a one column. Then we can directly, easily model to find the mean of the sample using the Excel. So I will type it's using the directly building function, average function, average, and double click it. Then you have to give the entire data set. I will highlight it and present it. Then you will find we got the mean for our data set is 90.925. I will go with 2 decimal places. That's mean round this value for 2 decimal. Then 19.92 is mean of the data set. Now let's go to find the marginal error to find the confidence bound. In order to find the marginal errors, so then I use the previous data set. We already found the mean is 19.93. I will record here. Mean here is 19.93. So then to find the marginal error, we can use this equation to calculate. Before we calculate this value, so we have to find the critical value corresponding to C confidence. In here, this example, we need to find the marginal error for 95% confidence. I will type here C is 95%. It's better to type here as the value is 0.95 instead of directly the type in the percentage value. And as previously, so in order to find the critical value means we have to find the one side area. That's mean one side area of the yellow region. It's 0.95 mean. How we can find the one side is equal 1 minus 0.95 divide by 2. Then we know the probabilities. Then only we have to find the C value, critical value, that's mean inverse. We are finding the standard normal value corresponding to this probability. So we can find it equal normal inverse, standard normal inverse, this value. Then we found negative 1.95. You can round here, round this value for second decimal. That's mean negative 1.cz. This is our critical value corresponding to the 95% confidence. I will type here negative 1.96. Then we have to calculate the marginal error. That's mean critical value times sigma. Sigma is known 2.4 and square root of it. This is the sample standard deviation. We know that using the central limit theorem, we can't get we can't consider sigma as a sample standard deviation. We have to divide by square root n. Then I will calculate here using the Excel. So first equal, this is critical value. We found this one. I will click here and times, then sigma divided by square root n. I will use the parenthesis. Sigma is 2.4 divide by square root of n. N is 40. And we have to type the two parentheses in order to input the correctly. So just sentence. Then you will see that we found the marginal error is negative 0.74. So I will type here E. That's mean marginal error is negative 0.774377. I suggest until you are getting the final confidence bound, keep the marginal error as where it was. That's been given from the calculation from the Excel. We don't want to change around, so otherwise it's we getting more error. And now finally we are going to find the confidence interval for the population mean. We already found mean and the marginal error. So in order to find the bounds of confidence interval, this is a left bound and right bound. I will type here first. It's confidence interval, left bound, that's mean minus error, and also right bound, mean plus A. Then I type here, then I will formulate equal sign. Mean minus A, mean is first click 19.93 minus and type from the keyboard this value, just enter it. Same way, equal sign, click the mean plus and marginal error, then just enter it. You will see that we found the left and right one. This is our confidence interval. If you want, you can round off for this to decimal. So I will type here equal round this value, comma 2. And here 2 equal round this value, comma 2. So then we highlight this. We found our confidence bound. Left bound is 20.67 and 19.19 is the right bound. Or we can write usually confidence bound 20.67 comma 19.19. So this is our confidence bound, confidence interval for the population mean when the confidence is 95%. Now we are going to find the minimum sample size to estimate mu. If you read this information and asking how many students' athletes must be included in the sample to be 95 confidence that the sample mean is within 0.5 hours of the population mean. This is telling us to find the sample mean is within the error. Within the error is 0.5. Then that's mean I will type here it is my marginal error for this question is 0.5. So then you will see that it's how we can find the marginal error from this equation. A is, where A is critical value times standard deviation of the sample. So then if you want to isolate n for the right side, this is meaning we are going to find the sample minimum sample size. We can use simple math to isolate n the right side, then you can find this equation in order to find the n minimum sample size. That's mean you have to find critical value given confidence interval, and also we have to substitute population standard deviation and divide by marginal error, then square it. So then here standard deviation, so we know from the previously it's given. Assume the population standard deviation is 2.4. So I will enter here as a 2.4 as population standard deviation. In critical value, so we have to find the critical value. How we can find the critical value? Accordingly, confidence interval. Here is confidence bound is 95%. So then we already found this. When you have confidence bound is 95%, then you can find the critical value is 1.96. So then I will type here critical value also 1.96. So now you have a 3 of value. Just substitute out value to this equation. So I will formulate using Excel. So that is our goal, to find the minimum sample size. I will type here equal. First click the critical value. This is times and standard deviation divide by marginal error. First get this value, then now in order to find the n, I need to square it this value. So I will type here equal, click in this value, square it. So you will see that we got the 18.5. So we have to use the highest whole number. So that's mean 89. Then our minimum sample size is n is 89. Okay, now wrap up what we did already so far. This is for section 6.1. We define confidence interval. We use the formula for sigma is unknown. And we did all the maths in Excel step by step. Up next, we will talk about what happens when sigma is unknown. That is when we switch from Z-score to T-score. Until then, keep practicing and remember, math is a skill. You get better at it every time you use it. You have got this. Thank you.